A very warm welcome to one and all. In our previous videos, we have studied related to worm and worm drives, the strength rating of worm and worm gears, also thermal considerations in worm gears. We have also studied related to the hydrodynamic journal bearings. Now in this lecture, we are going to study about the selection of flat belts from the manufacturer's catalog. Now we all know what are the different types of belt drives: open belt drives, cross belt drives. Again, we know the geometrical relationships for calculating the different parameters of the belt drives. Right? Now in this lecture, we are going to study about the selection of flat belts from the manufacturer's catalog. First thing we must know before selecting belt drive from manufacturer's catalog is what is given to us. We must know at the initial stages the power to be transmitted, the input and output speeds. That is, we are going to denote it by small n as input speed and capital N as the output speed. The input and output speeds known means which tells us what is the driving machine and which is the driven machine. Also, we must know the center distance between the two pulleys or the two shafts on which the two pulleys are mounted. Once these three things are known, we can select the flat belt from manufacturer's catalog by following the steps. Now, the first step is to select the belt speed and calculate the diameter of the pulleys. Now, in the initial stages, we are not knowing how much is the velocity of the belt or the belt speed. So, better way is to select the belt speed in the optimum range of 18 meter per second to 25 meter per second for flat belts. Right? Once we select any value between this range, we can calculate the diameter of the pulley using the relation of the velocity. V is equal to pi dn upon 60,000, where d is the diameter of the smaller pulley in mm, and as we want the velocity in meter per second divided by 1000, so this value is 60,000. So we will get the value of velocity, that is the belt speed in meter per second, right? Then we will calculate the diameter of the larger pulley using this relation: capital small d upon capital D is equal to capital N upon small n, where small d is the diameter of smaller pulley, capital D is the diameter of larger pulley, capital N is the speed of driven pulley, and small n is the speed of driving pulley. Now, using this relation, we can calculate the value of the capital D, which is the diameter of larger pulley. And the next step is to select the standard values of the diameter of pulleys, right? And then once we round up those values, we can calculate the actual belt speed for this selected standard pulley diameters, and then check whether the actual belt speed is in the range of optimum belt speed, which we have selected in the earlier stages. Optimum belt speed is in the range of 18 meter per second to 25 meter per second, and we can select any value of belt speed from that range. Then the next stage is to select the service factor or load correction factor. The service factor or load correction factor, it depends on certain parameters. First parameter is what is the type of driving machine. The driving machine can be electric motor. It can be an internal combustion engine with 4 or more cylinders, or it can be an internal combustion engine less than 4 cylinders. Next parameter is the driven machine. That is where we have to transmit the power, right? And then we must also know to how much hours per day the drive will be subjected to, right? Then depending on all these parameters, we can select the value of the service factor or load correction factor from this table, right? Different values are shown for different driven machines, for different driving machines, and for the working hours per day duty. So from this particular table, we can select the value of the service factor or application factor. Once that service factor or application factor is known, that is FA is known, we can calculate the design power in the next stage. The design power PD can be calculated by calculating the product of the service factor FA and the power to be transmitted, which we know in the earlier stages. And FA into power will give us the value of the design power. Once the design power is known, we can move ahead to the next step. That is to calculate arc of contact or angle of contact for the smaller pulley. Angle of contact or the arc of contact for the smaller pulley can be calculated using the geometrical relations. Here we can see theta s is calculated as pi minus 2 alpha, where alpha is equal to sine inverse d minus d upon twice c. D is the diameter of larger pulley, small d is the diameter of smaller pulley, and c is the center distance. Right? Here we will get the value of theta in radians. Right? Theta s is angle of contact or arc of contact for smaller pulley, and c is the center distance between two pulleys. Now, next step is to calculate the arc of contact correction factor, that is FT. We know that the angle of contact can be less than 180 degree. It can be 180 degree only when the diameter of smaller pulley and the diameter of larger pulley, that is driven pulley and driving pulley, if it is same, right, then the angle of contact or arc of contact will be 180 degree. Otherwise, it will be less than 180 degree or it can be greater than 180 degree. Greater than 180 degree will be in certain conditions only. Otherwise, the angle of contact or arc of contact theta will be always less than 180 degree. So we have to calculate FD, right, for the actual angle of contact, which will be less than 180 degree. If we get the value of the arc of contact, that is theta in degree. See here, in the earlier stage, we have calculated the theta as in radians. We have to convert it into degree over here for finding the value of FD. Right? If the value of theta is somewhere in between any of these two values, then we have to interpolate for calculating the value of FD. If it is exactly from these values, then we can directly select the value of FD. There will be no need of interpolation. Interpolation will be only needed if the value is not exactly from these given values. After calculating the value of arc of contact correction factor, we have to calculate the power, we have to select rather the power rating of built kilowatt from the manufacturer's catalog. This power rating kilowatt, right, it will be per mm width of belt per ply for 180 degree angle of contact and for the belt speed as 10 meter per second. This value we can get it directly from the manufacturer's catalog. See here, again I will repeat that the power rating of belt kilowatt, it will be directly obtained from the manufacturer's catalog, and this value which is given in the manufacturer's catalog is based, right, on the arc of contact 180 degree, belt speed 10 meter per second, and this power is per mm width, that is 1 mm width of belt per ply. Then we will go for calculation of modified power. Why it is necessary to calculate the modified power or the modified power rating? Because whatever power rating we have calculated from or selected from the manufacturer's catalog, it was based on the fact that it is for 180 degree angle of contact, and in our case it will not be 180 degree angle of contact, or it may be 180-degree angle of contact, right? Then it is for velocity 10 meter per second, and in our case the velocity will not be equal to 10 meter per second, and the value of kW is for per mm width of belt per ply, right? And so to accommodate all these things, we have to calculate the modified kilowatt or modified power rating, and it will be calculated by using this relation kW upon Fd into velocity upon 10, where kW is the power rating which we have selected from manufacturer's catalog, Fd is the arc of contact correction factor, V is the actual belt speed, and 10 is what we have considered, 10 meter per second. After calculating the modified power rating, we will go for calculating the product of belt width into number of plies. Belt width into number of plies will be calculated as the design power divided by the power rating, modified power rating, which we have calculated in the earlier stages. PD is service factor into power, and kWm is kW upon Fd into velocity upon 10. Rewriting these things, we will get the product of belt width into number of plies, which is given by this particular equation. Then the next stage is to select the standard belt width and number of plies from the manufacturer's catalog. Okay. So here, if we are knowing the value of this belt width into number of plies, going on trial and error method, we can exactly know how much number of plies and what will be the standard belt width for that number of plies. So based on that product, we can select the standard belt width and number of plies from this table. Last but not least, it is the calculation of the length of the belt. The length of the belt can be calculated using the relation capital L is equal to twice C plus pi into bracket capital D plus small d divided by 2 plus capital D minus small d whole square divided by 4C. We already know what is capital D, diameter of larger pulley, small d, diameter of smaller pulley, and C is the center distance. Hope everyone will understand this. Thank you very much.